Students, this question was asked in the year 2010. This was the second question asked from the chapter oscillations. The displacement of a particle along the x-axis is given by x is equal to a sin square omega t. The motion of the particle corresponds to, we can find out about the motion of the particle from its equation of motion. Students, you know, it is given x is equal to a sin square omega t. So there are four options given, student. First we have to find out whether this is SHM or not, simple harmonic motion or not. And how can we find whether a motion of the particle is simple harmonic or not? If we found the acceleration a is directly proportional to minus y or say minus x if the particle is executing motion along the x-axis, then the body is said to be executing simple harmonic motion. The acceleration must be proportional to the displacement, and students, there must be this minus sign so that the direction of motion is always towards a fixed point called the mean position or the point of stability or point of equilibrium. And if we multiply m this way, then this becomes, student, force is directly proportional to minus x, and this means the force is a restoring force. This is the basic requirement to see whether a motion is simple harmonic or not. So student, it is given x is equal to a sin square omega t. From this we can find out the velocity of the particle dx by dt. We know the velocity is the time derivative of the displacement vector or the position vector, or this is the time rate of change of the position of the particle. So this becomes, student, a d by dt of, we can write this sin square omega t is equal to half 1 minus cos 2 omega t. Okay student, 1 minus cos 2 omega t is 2 sin square omega t. So we write sin square omega t like this, and a by 2 we can take outside d by dt because this is a constant. Let us take this outside, a by 2, and this is 1 minus cos 2 omega t time derivative. So student, this d by dt of 1 is 0, and what of cos 2 minus cos 2 omega t? That will be equal to 2 omega, and this will be minus sign, so this will be plus sin 2 omega t. Okay student. Then students, the acceleration is dv by dt. The time rate of change of velocity is acceleration, or the time derivative of velocity is acceleration. So these two cancel, and we write here a omega sin 2 omega t. So dv by dt of d by dt time derivative of a omega sin 2 omega t. So this becomes, student, a omega is taken outside, and this sin 2 omega comes here, 2 omega. So this is 2 omega and cos 2 omega t, or this becomes 2a omega square cos 2 omega t. Okay student. And what is x? X is a sin square omega t. You observe x is equal to a sin square omega t. The position vector or the displacement of the body from its mean position is x is equal to a sin square omega t, and acceleration is equal to 2a omega square cos 2 omega t. On observing this, we find that, student, x, the acceleration is not proportional to minus, say here, y or x minus x. This is not proportional. Okay, here is the cosine omega t, and there is sin square omega t, and there is no negative sign. So student, this is not simple harmonic motion. So option C will be correct, students. Whenever such a problem is given, if the position vector is given, you double differentiate it to get the acceleration and see whether the acceleration is directly proportional to the minus displacement or not. From that you can decide whether the motion of the particle is simple harmonic or not, students.